Hi guys, welcome back to ToonBlend 3D. In this part, we're going to work on rigging and animation for the Low Poly Chibi Knight character. So let's get started. First, go to the Layout workspace. Here we'll use Rigify add-on. Press Shift+A and add armature. Then choose Basic Human. Then make sure the 3D cursor is at the world origin. Go to Edit mode, then open Data Properties. In Viewport Display, enable in front so the bones are visible in front of the mesh. Next, scale the armature and press period to set the pivot point to the 3D cursor. Then, press S to scale. Before we start adjusting the bones, enable the mirror option first so the bones stay symmetrical. Press G to adjust the position of the arm and leg bones. Check both front and side views to make sure everything lines up properly. Select the chest bone, press X, and delete it, since we won't be using it. Then select the upper torso bone, press X, and choose Dissolve Bone. Do the same for the head area so the neck only has one bone. After that, fine-tune the armature positions. Next, go to the Sample tab and add finger bones. Move the 3D cursor to the hand bone by pressing Shift+S, then snap the sample finger bone to the 3D cursor. Adjust the finger and press F2 to rename it as index finger, and make sure to adding .+L at the end of the name. Then press Shift+D to duplicate it and adjust it for the middle finger. And duplicate again for the thumb. Select the root of each finger bone and the hand bone, then press Ctrl+P and choose Keep Offset to parent them. After that, move the mouse pointer and press L to select all finger bones. Right-click and choose Symmetrize so they mirror to the other hand automatically. Reset the 3D cursor back to the world origin. Add a basic supercopy bone for the big chain. You can also use this bone for the visor if needed. Then parent this bone to the head bone. Next, add a simple tentacle limb to control the plume. Adjust it to follow the curve of the plume and press E to add more bones if needed. Then parent the root of the plume bone to the head bone. Continue with rename the bones for big chain, plume, head, and neck so everything is clear. After that, add basic supercopy bones to control the fabric edges of the character. Then select and hide the blocking bones by pressing H. Set snapping to face project and enable affect move, rotate, and scale. Adjust their positions and rename them properly. Press Alt+H to unhide the bones that were hidden before. Then parent all fabric edge bones to the hip bone. Select the bones and use Symmetrize. Then, to be safe, press A to select all bones and run Symmetrize again on the armature. Once everything is set, generate the rig. You can rename the armature before generating if you want. Click Generate Rig, then hide the meta rig. Then select the generated rig, then select all meshes, press Ctrl+P, and choose with automatic weights. Switch the rig to pose mode to check the result. Before fixing weight paint, set up the Bone Widgets using the Bone Widget add-on. You can get it from Wayne Dixon's channel or directly from the Get Extension menu in Blender. And I'm using the version from Get Extension, then setting the panel category to Item. Next, start adjusting widgets from the hands. For example, change them to cube shapes, edit the widget, then click to bone. Then, try Symmetrize Shape. If it fails, go back to the Meta Rig, symmetrize the bones again, and regenerate the rig. This usually fixes the widget symmetry automatically. After regenerating, the parenting to the characters should still be intact. Then continue adjusting widget shapes to make animation easier. Repeat the same steps if you encounter symmetry issues again. Next, check the rig deformation on the character to see which parts need fixing. Before that, switch back to object mode. First, we start with select the plume mesh. Go to vertex groups, find the plume bone group, and lock it. Then continue with delete the other unused vertex groups. For the helmet, keep only the head vertex group and do the same for the visor. For the head mesh, keep the head and neck related vertex groups. Continue with the big chain mesh, then lock the big chain and head vertex groups. Then switch to weight paint mode and adjust the weights so the big chain bone only affects the ring part, not the hook. Change the brush type to gradient to speed up the weight painting process. We can also use masking while weight painting, and directly click the mesh faces or press L to select face areas in weight paint mode. Here, the weight paint on the ring part of the big chain is already correct, so we just need to fix it so the hook mesh is not affected by the big chain bone. Red color means the mesh is strongly influenced by the bone, so we need to remove the weight there. Right-click and set the weight value to 0, then click and drag to apply the gradient weight. If it doesn't work, make sure the vertex group is not locked, so unlock it and try again. Blue color means the mesh is no longer affected by the selected bone. If you accidentally delete an important vertex group, like the head group on the chain hook, don't worry. Copy the vertex group name from another mesh. Then add a new vertex group to the big chain mesh, paste the name, and repaint the weights. Right-click, then set the weight to full, and make sure the hook mesh is filled and turns fully red on the head vertex group. Next, we fix the helmet mesh. There's one vertex that didn't get automatic weight paint before, so we manually paint it by filling full weight on the helmet mesh in the head vertex group. After that, we continue by checking the rig we fixed earlier in pose mode. Then we move on to check the body, especially around the waist and the legs. After checking, we can see that the fabric edge bone is still not optimal, so we fix the weight paint one by one. After that, test the fabric edge rig again. Once it feels correct, we continue fixing the leg part. After that, check the entire rig and try making a pose. Then, if everything feels good, we move on to animation. Next, we'll create a simple idle animation. Then I'll keep this part brief. I use a simple idle pose sketch as reference, which you can find on this channel's Pinterest account. In the animation layout, I'm using the Dope Sheet tab at the top, the nonlinear animation in the middle, and the timeline at the bottom. First, create poses one by one following the reference. Set keyframes for each main pose, with equal spacing. Then, between these poses, add secondary motion for accessories like the plume, big chain, and fabric edges. For some poses, change the keyframe interpolation by pressing T. For example, when the character wakes up in surprise, use back interpolation so the motion has a slight bounce. Then for other poses, use linear interpolation. To use non-linear animation, first create a regular keyframe animation, then click push down action. This converts the animation into strips. Then you can also re-edit the keyframes that have already been turned into this strip. You can rename strips, split them by pressing Y, and move them around. Rename tracks to describe the duration or purpose of each strip, which helps with timeline control. To focus on one strip, enable the star icon. Then, if no star is enabled, the top strip will be played. You can lock strips or delete tracks by right-clicking on them and choosing Delete. Then the same workflow can also be applied to camera animation. For rendering, you can make the background transparent by going to Render Properties, Film, and enabling Transparent. Then go to Output Properties, set File Format to FMPEG Video, Encoding to QuickTime, then Video Codec to QuickTime Animation, and Color to RGBA. If you want to render exactly what you see in the viewport, go to View and choose Viewport Render for either image or animation. With that, the Low Poly Chibi Knight project is finished. Thank you so much for watching from the beginning. Then, see you in the next one.